So let's take a look at what we have in the box itself. First off, we have the refractometer. There is also a small pipette for transferring samples, small screwdriver, and a bottle which in this case contains distilled water. So, what is a refractometer going to measure? Well, as the name would indicate, it measures the refraction of light through a liquid. As the light passes through the liquid, its path is diverted by dissolved solids within the liquid, so the greater the diversion, the more dissolved solids. This is useful for checking on the quality of fruit, for example, as those dissolved solids are made up of sugar, and this can be an indication of ripeness and sweetness. As the fruit ripens, so does the sugar, and the greater the refraction of light. So, let's take a look at how we actually use this device. You will see that the penetrometer has a clear glass plate at the front with a clear plastic cover that folds over the plate, and then a viewing port on the reverse. Other features include a screw under this black cap which can be used for calibration, which is why you have the handy small screwdriver. The pipette will often be used for transferring liquid samples onto the glass plate. We use it particularly for transferring distilled water in terms of calibration. So, in terms of products that this can be used for, grapes pretty regularly, apples, pears, cherry tomatoes, essentially any fruit product which has a sweetness level that can be defined by the quantity of sugar. Let's have a look at our samples. With an example of a cherry tomato, which we will simply slice in half, your aim is to extract a small quantity of juice from the product and place it onto the clear glass plate on the refractometer. This may mean slicing the fruit in half, or in the case of apples, I prefer to take a wedge. Once you have it on the refractometer, you want to get an even covering of fruit juice across the plate and then cover the plate using the plastic cover. You will see that the juice is then spread evenly. Looking through the viewport on the other end of the refractometer, then you can then take your reading using the scale provided. Always clean the plate thoroughly of any residual juice in between samples, and to avoid anomalous samples, we always recommend taking a range of readings from within any batch. In the case of apples, and similarly pears, we recommend taking a wedge shape of fruit rather than slicing the whole fruit in half. You can then use your knife to score your wedge several times, which will make it easier to squeeze some of the juice onto the glass plate of the refractometer in the same way that we did with the cherry tomatoes. Once again, you are aiming to get a nice even covering of juice over the glass plate. Lay the plastic cover over the plate and look through the reverse to take your reading using the gauge. In this case, higher than the tomatoes, more in the region of around 14–15%. Before once again cleaning your equipment thoroughly. A word on temperature, as you may have been used to an adjustment chart for temperature when using a refractometer. The equipment manufacturers now recommend that this equipment be used at 10 degrees and up, and that your sample is the same temperature as your equipment. A significant difference in temperature can result in a reading that is perhaps 0.2 or 0.3 of a percentage out, so worth having a probe handy if your samples have been in chill just prior to testing. In terms of selecting your sample, take multiple fruit, whether it be small or larger fruit, and always be careful to discard any products which may show defects likely to affect the readings.